Welcome back. In this lesson, we're going to take a look at sector area and arc length. So two different topics that have a lot to do with each other. So sector area, we learned before area of a circle, right? So that'd be like this whole circle here. Sector area is, let's do this right, maybe just finding a portion of the circle. That'd be a sector. So we're going to take a look at that. And arc length is, we learned before, finding the distance all the way around the circle. That's the circumference. But the arc length, we're just going to look at little bits, maybe just like one distance around, just a portion of that. All right. So we're going to start off with arc length. So we have a circle here. And we have a central angle and arc measure of 110 degrees, right? And it looks like a radius of 3 meters. So you learned before how to find the circumference of a circle. It is 2 times pi times the radius. We're going to use that in this. We just want to find the distance here from here to there. So it's going to be a number that is smaller than the circumference. It's going to be a portion of that circumference. So let's first find the circumference. So the circumference will equal 2 times pi times the radius here is 3. I'm going to put that in my calculator. 2 times, oh, wrong button. 2 times pi times 3. We get 6 pi or 18.8. C is equal to 18.8. Alright, so that's the distance all around the circle. So a circle with radius 3 would have a circumference of 18.8. Now I know that it's going to be less than that. I know it's going to be less than half of it just by looking at it, right? This distance from here to here should be less than half of my full circle. So we just want 110 degrees of this. So what we need to do, we want 110 degrees of 360 degrees. That's the proportion that we want, right? We just want this little piece of the pie, which is 110 out of the whole 360 degrees. So if we take that fraction and multiply it by our circumference, we'll get that proportion that we want. So let's do that in our calculator. I have this already, so I'm just going to say that times, it'll be more accurate that way. The answer times a fraction 110 over 360. And I get 5.75958. We'll call it 5.8. So about 5.8 meters. That would be the distance for just this section here. Right through there. Which is less than our circumference, which is what we were expecting. Alright, we're kind of going to do the same process with area of a sector. Alright, so let's take a look at that. So we have the same setup here, 110 degrees. We have our radius is 3. And we want to find the area of this sector now. So we know the area of a circle is pi r squared. So let's find that whole area first. The area will equal to pi times 3 squared, which is 9, right? So the area is equal to pi times 9. Let's see what pi times 9 is. Pi times 9 is 28.3. So we had meters before. We'll stick with meters. So we'll call this meters squared then for the area. So 28.3 meters squared is this whole circle. The whole circle. So we only want this little portion of the circle, this 110 degrees of our 360 degrees of the circle. So just like before, we're going to look at 110 of the 360 degrees and multiply that by the whole circle. So we only want this 110 degrees of the whole 360 degrees of the circle. So we can look at the ratio 110 over 360 and multiply that by our total area of the whole circle. So it'll give us just the percentage that we want. Alright, so I'm gonna, once again, times put a fraction in here, 110 over 360 is equal to 8.64. So 8.64 meters squared, which is just a small portion of our 28.3 total. So you always want to go back and make sure that makes sense. Okay, the whole circle is 28.3 meters squared. This part right here, yeah, it could be 8.64. I bought that. Alright. The last piece of what we're going to look at today is finding this little piece right here. All it is we have a chord connecting the two endpoints of our central angle there. Alright? So what we're going to actually do, I'll draw it out here. We found this earlier, right? Uh-oh, power's going to die. Alright, we're back with power. So, I was saying, if we take this sector out of here, we found that area to be 8.64 meters squared. So this was 8.64 meters squared. But all we want is this portion of it. So we can subtract out that triangle there. Alright? So the idea is we're going to try and subtract out that triangle. So to do that, you guys are going to like this. We're going to do a couple different things. Let me first erase this so I can draw on it. We need to find the area of this triangle. So to do that, I'm first going to draw a little radius there. We know that radius is 3, right? So this is 110 degrees. Draw a right angle there. We're going to split that in half. So this is 110 degrees, so that means that this is 55 degrees, right? So in order to find the area of the triangle, we have to do 1/2 base times height. So we need bases and heights of these triangles. I just have an angle and I have one side. So we're going to go back in our toolbox of knowledge and use SOHCAHTOA to solve for my missing pieces. Alright? So in this triangle we have 55. Let's try to find this here first. That is the opposite and the 3 is the hypotenuse. So opposite and hypotenuse, I'm going to use sine. So the sine of 55 degrees is equal to the opposite over the hypotenuse. If we want to find out x, we need to multiply both sides by 5, right? Times 5, so 5 times the sine of 55 is equal to x. 5 times the sine of 55 degrees is equal to, it gives me something crazy, 4.0957, about 4.1. So x is equal to 4.1. That means this is also going to equal to 4.1. We are missing this side here still. And we need that because in our triangle, we're going to use that as the height. So we can say the base is 8.2, but we need that height there. So to do that, we could use a couple different things. Let's say we'll call this y. We'll use this 3 again. So that is the hypotenuse, and the y would be the adjacent. So adjacent hypotenuse, we use cosine. Let me switch colors up here. So we could say the cosine of 55 is equal to the adjacent y over the hypotenuse 3. So in this problem, we're going to multiply both sides by 3 to get the y by itself. 3 cancels out, and we get y is equal to the 3 times the cosine of 55. 3 times cos 55 is equal to, is that right? I don't think it did it correctly. Let's try it again. 3 times the cosine of 55 is equal to 1.72. Looks better. Y is equal to about 1.7. So in this triangle here, our base is 8.2 and our height is 1.7. 1.7. So I can use my formula. Let me erase this to get a little bit more room. Area is equal to 1/2 base times height, right? So area of a triangle is equal to 1/2 times the base, 8.2 times the height, 1.7. Put in my calculator. 1/2 is the same thing as 0.5 times 8.2 times 1.7 is equal to 6.97. Alright, 6.97. So that's the area of this triangle. So if we want to get just this area here, we need to take the area from the last problem and subtract out the triangle. So this 8.64 minus 6.97, and that's going to give us that little sliver that we want. Alright, 8.64 minus 6.97 is equal to 1.67. So 1.67, I think that was meters. Oh. 1.67 meters squared will be just this little sliver here. Alright, that is all for today. I hope you enjoyed and learned something. We'll see you in class.